In this video, we will take a look at the tools and techniques for putting together a working drawing. We're going to use the bearing plate as our assignment here, but this applies to any working drawing that you would need, either for manufacture in the machine shop or specification for a supplier, etc. So I'm starting with my SolidWorks window open, and I'm going to start by opening a new drawing file. Now, I'm assuming you've already set up a drawing template using the system options file locations, or you have saved a blank drawing and you plan to use that as a template. So I'm going to go to New, and I'm not using Novice here, I'm using Advanced, and I'm going to open one of my inch drawing templates. So I'm going to click inch drawing. And now I have an inch drawing part file here. It's an older sheet format, so it has my third angle projection note, but otherwise it's a pretty standard drawing template. So if you have your bearing part open, because you're doing this right after you finish the model, that would be in this window right here. If not, I'm going to browse, and I'm going to go find my bearing plate, and now I can put in these drawing views. So I'm going to put in my front view and a right side view, and I'm in projection mode, so I'm already going to just add in an isometric view at the same time. Now the top view and the right view are nearly identical. They do not provide different information, so I'm not going to put in both. I'm just going to choose one of the secondary views. Check mark puts it in, or escape key finishes the tool, and I'm going to first off change my views. So this view is all right. It's a little big, but I think I'll have room for my dimensions, so I'll leave it. It's a scale of 4:1, so that should be okay. 2:1 is probably sufficient here as well. So that is up to you. There's no hard and fast rule about the scaling as long as it fits on the page. This should be half of the scale of the front view. So I'm going to turn on shaded with edges on the left side. I selected the drawing view, and then these tools come up. I'm also going to use a custom scale and select 2:1 to shrink that drawing view to half size. Check mark closes those tools. And this just wants to settle right in that upper right hand corner. I notice there are no hidden lines to expect in this front view, but I should be able to see the through holes in my right view. So now I'll show you two things. So if my front view, which is the parent view, it's the first view I inserted, is the correct view, all of my drawing views will have that view. It should be a display style of hidden lines visible, not wireframe, because that makes all the hidden lines look like visible lines. But I want to be able to see where there are edges through the part. So this is showing me the holes, the edges of the holes, right? Okay, so when I do a drawing, I have several steps. My first step is get the drawing view in. Seems intuitive, right? My second step is usually to add annotations that are not dimensions. So here I mean center lines, center marks, anything like that. So I'm going to start with my center mark, and I will highlight an issue we have because of our scale. SolidWorks scales center marks along with drawing views, which is among my, I think it might be my absolute top gripe about SolidWorks, is that center marks should not scale. I've never understood this one, so I will show you how we fix it. When we turn on the center mark tool, all of these options come up. You have separate slot center mark options, you have manual insert options. I want to do a circular center mark because these are on a circular bolt hole pattern. So if I choose the circular option, I choose my holes in a circular manner, then my center mark is a circular one that indicates that bolt hole circle. I have to, however, turn off document defaults and divide by the scale. So I'm going to divide by 4 because my scale is 4:1, and that is a proper center mark. Like I said, I don't know why. Oops, I forgot to hit check mark. Check mark puts it in, not escape. So let's do this one more time. Circular, around the circle we go. And we turn off document defaults and we divide by 4. check mark puts it in. So those center marks should be, I think it's 1/8 of an inch side to side or a 1/16 from the center out, and it should not scale with the drawing view. So that's our center marks. You'll notice it also included the center circle, which is perfect. And now I'm going to add center lines on these holes. I choose select view. I click on that view, and there are my center marks. Check mark puts it in. So now I'm going to give this a quick save. I already have one going, so we're going to do this bearing plate 2. Oops. I highly recommend all caps here. It updates down here, which is perfect. Okay, so all of my annotations are in. It is time for dimensions. So let's look at a couple of ways we dimension these parts. Smart dimension is helpful. I can smart dimension by clicking on an edge and putting information out, or clicking out to the first standard positioning. I can also, click on this circle and put in its diameter. Okay. When I have dimensions, I can on the left modify the text. So for here, I can put for press fit as the whole dimension, and it doesn't change the link for the 0.375, but it does add the extra text. Another smart dimension I have here, I can indicate that this is, let's see, display as diameter. I can display the diameter of that bolt hole circle. I can line these up a little bit, and I could also indicate the thickness of the material. I know this is 1/8 inch material, but I need to indicate that somewhere. The one that I can't do with a standard smart dimension is the 4-hole pattern. I'm going to put in a hole callout, and here is why I recommend using Hole Wizard anytime you would like to put in hole that's associated with the hardware. It tells me the quantity, it tells me the depth, it tells me the diameter. If there was a countersink, a counterbore, or a thread, that information would be here as well. This is the absolute easiest way to indicate holes for hardware. Clearance holes are pretty simple, but even then, to know exactly how many holes in the depth, I need to use a Hole Wizard. So in the part file, use Hole Wizard when you're going to be making holes for hardware, or making multiples of holes. Most of our holes are for hardware. So there you go. So that's how we dimension these. You'll notice that dimensions click to certain spots. That's ANSI standards. So as you read through the text chapter on dimensioning, there are standards for where dimensions go. There are standards for how tall dimensions are on the page. There are standards for the exact dimension and ratio of the height and width of the arrowhead. All of this is very precisely standardized by international governing bodies. So if it seems like I'm being picky, it's because I want you to understand those national standards that are absolutely critical in our industry. So that's the dimensioning aspect. Final bit would be to put in a note. I usually like to include material. So here I need you to decide how you're making your part. Mine's going to be aluminum. Quantity, when you're making an assembly, how many of each part do you need? It's good to specify. Do you have an expected tolerance? So what we usually do is specify that 3 decimal dimensions are, and here I'll show you how to find that plus and minus. Actually, I think I forgot a word, dimensions, plus or minus, and then I specify 5/1000ths of an inch is pretty standard. You might have a dimension or a particular feature that has to be even more precise, or perhaps is less precise, so that's up to you. 5/1000ths is a pretty good standard to hold, and we can certainly meet that in our machine shop. Now, that's assuming it's aluminum from the machine shop. If you're 3D printing, I don't know what that tolerance is. Go investigate it. You tell me. What's a good tolerance? What's an expected tolerance on the 3D printers that we're using? Last step would be check that your name's there, check that the scale makes sense, check that it's a named part file, and check that it has a date. I save it, and then I also do a save as to get it into a universal format. So here I'm going to warn you, if you send someone a drawing file without the part file, they can't see the drawing. I'll show you what that looks like here in a follow-up video, just as an example, but know that I can't open drawing files that don't also have the part files. Also, if my standards are different on my computer, I will see what my standards say for your drawing, not what yours are. So PDF is the safest way, or eDrawing. Those are the two safest ways to share drawings amongst your peers, unless you're all working out of the same exact folder. So use caution with that. And I think that wraps up how we do dimensioning in SolidWorks. This is actually a pretty complete view. So I will take questions on the discussion board, or you can talk to your instructors in class if anything is left unanswered.